Hello, my name is James Roach. I am a senior electrical engineer at the University of Scranton, and the purpose of this video is a further update for my 2016 robotics class senior project, which is an autonomous deliverer, or a factory warehouse. So where I left off in the last video was a brief update as to what has been done, what still has to be done, and some further possible areas that can be looked ahead upon. So firstly, I mentioned about the Raspberry Pi and how that was the microcontroller we chose to use. And the main reason for this, or an issue, was that we needed to have it act as a Wi-Fi module, since the PCs at the school do not have an HDMI port, so routing to the Pi would be pretty much impossible without them acting as a Wi-Fi module. So this was attempted to be done through a walkthrough on Adafruit.com with a Wi-Fi dongle, which we had, and this was tried about 3 or 4 separate times with no success in either direction. So what was done was we talked to a professor who used Raspberry Pis for a Micromouse class that he has, and so we were able to talk with him, and he was able to give us his Raspberry Pi, which actually has the Wi-Fi already hooked up onto it. So that was our fix for that, and we are actually able to write to the Pi now and save files on it. With regards to the motor hat, that has been soldered with all the pins necessary, and the battery has been hooked up to that along with the motors. So in essence, the Raspberry Pi should, not the Raspberry Pi, the Micromouse robot should be able to run fairly soon. Now, with regards to the line follower, that has been designed successfully and tested. The design was basically to use but 2 phototransistors, one on each side of the circuit built, in order to detect a line. But in order to do this, prior testing had to be done with regards to voltage levels for a comparator circuit. And so what was done was we just placed a piece of black tape on a piece of paper, and we put the phototransistor over that and read the voltage level, which came to be 1.2 to 2 volts. Then when it was halfway on and halfway off the line, which was 2.5 to 3.5, and was fully off the line, which is 4.6 to 5 volts. And based upon this, a simple circuit diagram had been made where 5 volts would come into the phototransistor, which would be connected to an LED, and then a comparator circuit would be used to compare values to say whether the phototransistor was on the line or off the line. Now, the reason we chose to use a phototransistor was simply it was a cheap alternative to buying an analog digital converter, or ADC. Since the Raspberry Pi doesn't have analog input output on it by itself, and so, as I just mentioned, this resulted in the team building a comparator circuit for the line follower. And another hardware aspect is the barcode reader or scanner, which was bought from Adafruit.com, and it is known, or I should say, it is the barcode reader / scanner module, or CCD camera with a USB interface, which is primarily what is needed, since with the USB interface it is able to be plugged into the Pi. But there is an issue with this, since it's camera based and not laser based. The scanning area, it has to be at least 4 inches away for it to scan. So this just means that the warehouse has to be spaced out properly according to that, based upon the full dimensions of the Micromouse and how far away it has to be to actually scan it. Now, with some specs for that, it has a plus or minus 5% DC power and 80 milliamp power consumption. It has been successfully tested with custom barcodes and it reads them properly. And what is important about this scanner is that when it is plugged in, it acts as an HDI keyboard. So we don't have to have anything write for it, since it already scans that and types in what it needs to already. But there is also an issue we found with this, is that it is not automatically scannable. So what has to be done is it has to push a button in order for it to work. But a fix for this has been come up with by attaching wires to the ground of the scanner and the button itself so that it scans automatically. And now with with regards to the warehouse and the design of that, the materials have been bought, and what was bought for it was 2x4s, a 4x6 sheet of plywood, white paint, and then nails and other aspects of it for it to actually be put together. Now the design of it is that it's going to be on the plywood, and all around that is going to be the 2x4s, just as a preliminary backup or action in case the robot, there's a flaw or that it does not go as planned and it might possibly fall off. So to prevent that, we just have walls around it, and then obviously we have our shelves, 2 on the sides and 1 big one in the middle where a package will be held on each side of it. And we have 3 separate docking stations for shipping, the bot location, and the delivery. And lastly, what I'll be talking about is the intercommunication aspect between the robots. It had been suggested to use, or I should not say suggested, prior to being suggested to using what I will go over in a minute. We were looking up separate methods based upon the Raspberry Pi and everything, so we originally thought of maybe using master-slave or an ad hoc, but it was suggested to us to use a fit PC and hook that up to a monitor, and then based upon that download FileZilla so all the files could be transferred between each robot in order for them to communicate with each other. And this has been successfully run, and we are currently in the process of writing code for the actual movement of the robots and the algorithms. So wrapping everything up, the next video will be going over basic code and how that code was written, the main basis behind the code, and it will be posted shortly. Thank you.